Lesson 45, translating between words and inequalities. Now we've done lessons earlier this year when we were going from expressions, translating from words to expressions and vice versa. This one is very similar. The only differences are we're not going to do expressions, it's just be an inequality. And an inequality is just a mathematical statement comparing two quantities that are not equal. So you're going to have a comparison symbol, like the less than or equal to. So the less than or equal to sign would be this. You'd have greater than or equal to. You would have the less than sign, and you'd have the greater than sign. So we'll be using those in our lesson today. So here we want to translate sentences into inequalities. The first one has been done for you. The quotient of a number and 2 is less than or equal to 6. So remember, quotient just means the answer to a division problem. So division, so the quotient of the number and 2, so they put the variable divided by 2. So the answer of that is less than or equal to, so they used the less than or equal to symbol, to 6. And there you have your inequality. The second one here, half is greater than the product of a number and 3/4. So half is greater than, so I need to use the greater than sign, greater than the product, so the multiplication of a number and 3/4. I'm going to write it with 3/4 n. If I put them together, then I put the coefficient in front of the variable. Otherwise, you could put n and then use the multiplication symbol 3/4. Other examples, the difference of a number and 2.8 does not equal 8.2. So again, the keyword difference means subtraction. What am I subtracting? A number and 2.8 says does not equal. So the equal sign with a slash sign through it, not equal 8.2. The sum of the product of 20 and a number and 75 is at least 195. And I put down in parentheses here, at least means greater than or equal to. Okay, so the sum, I'm adding two numbers. When am I adding? The product of 20 and a number, so 20n and 75. It says at least. At least, again, remember, means greater than or equal to, so it cannot be lower than 195. So there's my inequality. And the last one on this slide, the difference of 3 and a number is less than 0. The difference means a subtraction. Subtraction of what? 3 and a number is less than 0. And there I have my inequality. Other examples, the sum of a number and half and 1/3 is at most 5/6. At most means less than or equal to, so it can't be more than 5/6. So the sum means the addition of a number and 1/3 has to be at most, so less than or equal to 5/6. The quotient of 1 and a number is at least 8. So the division of 1 and a number is at least. So it's greater than or equal to 8. And the product of 3 and the sum of a number and 7 is at least 1. So the product, multiplication of 3 and the sum of a number, so I'm multiplying 3 and the sum of a number and 7. See how I put that one? So the product of 3 and then the sum, so the answer to an addition problem of n and a number is at least. So it's got to be greater than or equal to 1. And a few other ones. The quotient of an unknown number and -2 is greater than the opposite of 9. So the quotient, the division of an unknown number and -2 is greater than the opposite of 9. The opposite of a positive 9 is a -9. 0 is less than or equal to the difference of twice a number and 8. And the last one, the sum, so addition, the sum of half a number. Or you could write, instead of half times n, you could do n divided by 2. And 3 does not equal 15. Now we're going the other direction, so we're translating the inequality into words. The first one, 6 is greater than the sum of a number and 8. Next one, we could say the product of 2.5 and a number is less than 15. And there's other ways of writing it. That's just one way. The next one, we could write the product of -2 and a number +4 is greater than or equal to -8. Again, that's just one way of writing that inequality. A couple other ones. 3x minus 6 is less than or equal to -30. We could say the difference of the product of 3 and a number and 6 is less than, or instead of saying less than or equal to, we could say is no more than -30. Next one, we have n plus 3 divided by -2 is greater than -3. We could say the sum of a number and 3 divided by -2 is greater than -3. And the last one here, we have the difference of a number and 5 is less than 8. There are a few other problems on this PowerPoint you can work on yourself. Like these, if you want more practice, you can work on some of those. And then this next slide, there's a couple other problems you can work yourself. Let's get to some application problems. When we have an application problem, there are a couple ways or a couple of steps to follow in order to solve these. First, you need to determine your unknowns. What are your variables? Secondly, you need to determine what inequality symbol you're going to use. So look carefully at the keywords used. And then thirdly, translate the words into symbols and solve. So here it says Jonas is purchasing 15 screen printed warm-up suits for his soccer team. He can spend $1,000 at most. There is a setup fee of $25 for the screen printing. What can he spend at most on each suit, including tax and printing costs? So keyword at most. So that means it can be no more than, but it can equal 1,000. So that means I know I'm going to be using less than or equal to, so it's got to be less than or equal to $1,000. They're purchasing 15 suits. We don't know the cost. So I'm going to put the C with the 15 because they're buying 15 of those. Plus, you have to pay the setup fee of $25. Now, we could actually solve for C, but right now that we'll get to in another lesson. Right now, we just wanted to write our inequality. Next application. Carol buys a large bottle of juice for $4.50 and apples for 25 cents each. Write an inequality for how many apples she can buy if she can spend no more than $15. Now, a key word in here is each. So 25 cents each. So that means I got to have the variable with the 25 cents. So Carol buys juice for $4.50 plus she buys apples, and each apple costs 25 cents. But we don't know how many apples she's buying, so I'm going to put an A because it says write an inequality for how many apples she can buy. So I need to have a variable. I'm just using A for apples, and she can spend no more than, so it's got to be less than or equal to $15. So there's our inequality. And our last one here, the lowest temperature at which a piece of beef can be cooked rare is 140 degrees Fahrenheit. The formula used to convert degrees Celsius to degrees Fahrenheit is 9/5 degrees Celsius plus 32 equals degrees Fahrenheit. Write an inequality for the equivalent reading in degrees Celsius for a piece of beef cooked rare. So I'm going to start off with the formula that they gave us right here. So it'll be 9/5 degrees Celsius plus 32. But they said the lowest temperature at which a piece of beef can be cooked rare is 140 degrees. So it cannot be lower than that. So it's got to be greater than or equal to 140 degrees Fahrenheit. But since they gave us the degrees Fahrenheit, I can plug that into our inequality. So this would be our inequality for an equivalent reading in degrees Celsius. So that is our lesson today on translating into inequalities.